There we go. Okay, so I'm going to be talking about automation with the FEMAP API. Some of the other presentations have mentioned this. This is going to be sort of a broad overview and a quick introduction. We've done seminars and trainings on the API in the past, so some of this you might have seen it before. But there's a lot out there, and it can be pretty dense. So I think it's kind of nice to take this in small chunks, and especially do it before lunch, so we're not too sleepy while I'm up here typing away some code. Quick overview: what is it? How do we use it? We'll take a look mostly at existing programs. I think that's the best place to start, is just figuring out what's already out there, how you could modify those where they're useful, and then we'll just gently kind of dip into writing your own programs. Okay, so the API is the application programming interface. This is basically how we can drive FEMAP with a script. You can use a variety of different codes. The stuff I've been working with is VBA, C, C++. I believe it supports Python, C# now. So there's a wide range of programming languages that you can use. It's important to remember that your program is not part of your FEMAP model. It is an independent entity, and the API is really the conduit there that communicates. So we'll be looking at some of the programs in the FEMAP API programming window. As the note shows here, it looks like it's a part of the FEMAP session, but it's not. It's really just an editing tool. But it's a very nice editing tool. It's kind of nice to have it docked within FEMAP and get some live feedback as you modify your program and run it. So here's the major components of this. We're going to have, in this case, VBA code. The application programming interface is what communicates with FEMAP to deliver that code, those instructions. But it's not necessarily just going to be a list of instructions. You can record a macro in FEMAP and just basically turn on the record button, record your clicks, and play it back. And that works well for very repetitive tasks. We're going to be doing something a little bit different, writing our own from scratch. There's a little bit more customization that way, and we're going to be using object-oriented programming for that. Now, before we take a look, I just wanted to put this disclaimer up here. I am not a programmer. I've never had any programming classes. Most of my stuff is self-taught. So take everything with a grain of salt. If you guys have any feedback, have some proper skills, I'd be happy to discuss this with you. This is really just a collection of programs that I've written, colleagues have written, stuff that's available with the FEMAP install under custom tools, etc. Let's jump over to FEMAP. All right, so I think there's two main places that you want to start with API programming. First is finding the API programming window. So under tools, you've got this here. Oh, there we go. All right, so tools, programming, API programming. So here's the program files where you can actually just record a macro. You hit record, start clicking the buttons, it records those, or you can use the API programming window. Now this is a window pane, just like anything else in the interface here. You can dock it wherever you want. And this is starting out with basically a blank canvas for our programming. A good place to start would be the classic hello world, where we could ask FEMAP to just write something to the message box. You can see there's some options here for autocomplete, and we'll talk about this a bit more, but you don't have to type everything out perfectly. It kind of guides you along as you go, but we can just type in a little hello sim. And this is one of the most useful tools, this FEAP message, or one of the most useful methods, because you can write information to the message window here. So whether you're trying to do some post-processing, print information about your model to the message window, Whether you're trying to debug the program you're writing itself, you can print useful information here. So I always think this is a good place to start. The other good place to start with APIs is the custom tools toolbar. So you will see here that we have custom tools. Failing to see this. Oh, custom and user tools. So this will set up a little toolbar here. And this really just looks like a drop-down menu with lots of different options in it. And I would really recommend spending some time to explore these different options. They're categorized by geometry, meshing, post-processing. But all of these are really just different API macros that are available to you, and they come with the FEMAP install. So if you find a particular one of these that you think is useful, this view color swap is an interesting one here. You want to change it for printing, back to a different color for modeling. You say that's very useful, but I want to change it. How does this work? What does this look like? You can open up any of those programs in custom tools in the API programming window. I'm going to go to the directory where FEMAP is installed. I go to API, I take a look. Views was the folder that the subcategory I was just looking in, and I can open up that particular macro and see the actual code behind it. So I'd say these two tools is really the best place to start. You have to use the API programming window. If somebody sends you a macro to use, that's where you can open it up and hit play and use it. And then the custom tools is a great starting library of tools to use and sort of a starting point for writing your own code. Now, this isn't intended to be a full-on training session here. So I want to talk a little bit about some of the syntax, but I'm not going to get into it too deeply. This is a section from our API training class, and it talks about some of the different types of objects you'd be working with. So in that little hello world example, I was using the FEMAP application object. I was asking FEMAP to print something out using the GUI. There's also tool objects like sets. You might want to create a set of nodes or a set of elements for post-processing. Really, anytime you click on something within FEMAP and put it into a entity selection dialog box, a set is what's collecting those entities in the background. And then there's actual FEMAP entity objects, nodes, elements, groups, views. Earlier, somebody had a question about managing groups and updating groups. There's tools within the FEMAP GUI to do that. There's also some macros, some APIs that we've written that help clean up groups or automatically update those. So I'll have, in addition to the custom tools, I'll have a full library of useful little programs for you guys on our website. The help manual. So this is something that is critical even after working with this for years. It's something that I always have open next to me as I'm writing the program. There's lots of information in tables like this that are useful to use. So I think part of it is maybe having the help files and learning to navigate the help files. And then another part of it is really maybe saving certain sections of those help files, tables like this, you're gonna reference regularly into some sort of document, have a quick access. But my main advice about that is just embrace it. Even after all these years, I can't really do much without having the help files there. Just think of everything you know, how FEMAP works and all the different options and commands you have in FEMAP. They have a corresponding object, method, and property in the API. So it's not really something that you just carry in your memory. Embrace the help manual and use it as much as possible. So kind of backing up a little bit to the object-oriented programming, how does this work? How does the syntax work? How did I know how to kind of put together that message, the hello world message? It really always follows a similar syntax. You're going to have your object, whatever is actually doing the commands for you. You're going to have your method, what you're asking that object to do, and then it's generally going to have inputs and outputs. So we've got this obnoxious little example here with Mike. We're asking him to go get an apple, give him money in a car, and he's going to come back with an apple. This translates over to FEMAP with this box here you see used all over the place. This is really what you would be having kind of behind the curtain there. We have a set object. We're going to have something to carry this information, or nodes or elements or whatever we're going to be selecting. We're asking that object to use the select method, which means this box is going to pop up in the GUI. And then we're telling it some information. What type of entities do you want to restrict the user to selecting? Do you want to clear out any information in the set beforehand? And do you want to have some sort of message across the top? So I think this page here is kind of almost a bit of a tool of reading existing APIs. If you could have this next to you on your desk and look at existing APIs, you'll start to be able to identify the objects, the methods, the inputs and the outputs, and start to understand how this ties together. Here is another example of what you might see in the GUI along with a code or a script for the API. So what this is going to do here, this program on the side, would actually print out all of the different material properties for this material card. So I'm asking FEMAP to create an application object. I'm using a material object. Here's our select method for the set object, where we're asking the user to pick materials. So if you were to run this program, you'd have the entity selection dialog box pop up. You could click whatever materials you wanted in your model. And then in the message window, it'd list out ID, modulus, Poisson's ratio, etc. Now, this isn't a terribly useful program in terms of gathering that information, but I'd say it's really useful in understanding how these programs work, because what I've labeled in each of the fields here corresponds to extracting that information using the API. So it's really a visual guide. If you wanted to go in and modify material properties for a bunch of different composite materials, you could have, well, there's now some built-in tools in FEMAP that might be making some of my macros obsolete, but you could have a spreadsheet. You could access these different properties one at a time, update them. There's definitely still some applications for this. Whenever you kind of run into a dead end with the GUI where I wish this command was built into FEMAP, they're probably either working on integrating it to FEMAP, or you can take an existing macro and update it to do what you need to do. Okay, so I want to use the rest of the time to just explore some of these existing programs, show you what's capable, and maybe later on during the lunch break or over the computers over there, if you guys have specific questions, we can dig into this a bit more. Okay. So within FEMAP, a couple of different categories here. I would say that from a post-processing perspective, there's some very useful things, ways to automate repetitive tasks, or ways to eliminate the potential for error by having to manually set things up. One of those would be an output vector switch program that I wrote. I think this has actually been updated by the FEMAP team, is now available in custom tools. But let me open up an example model here. So here we have just a simple plate model. It already has results. Contour these results. Now, one thing I found myself wanting to investigate a bit more in some of my stress models were, what type of stress is this? Yes, I have a high von Mises stress. Is it tensile? Is it compressive? I want to know more about it, but to switch through different view settings and different post-processing settings was a bit slow. So we wrote a macro to automate some of this. Take a look here. And this one is actually designed for an older version of FEMAP. The updated version is in custom tools. But every time I hit play on this macro, It changes from minor principal stress. It also flips the legend, so it's going to be highlighting our most compressive stress areas in red. I hit it again, it cycles back to von Mises, switches our legend around, and I do it again and it goes to our major principal or tensile dominant stress. So this is a quick and easy way to get a quick look at the different types of stress in your model without going into view options and the post-processing toolbox making these changes. Now, again, this is just a good starting point. You might want to change colors, change the specific output vectors, and so on. You could modify this to work with composites and be looking at failure indices or strain values. So it's a simple tool, sort of a simple architecture, but it's a great starting point for automating some more of your post-processing tasks. I'm going to go ahead and dock this, make it a little easier to see. Another tool that I'm not sure if it's in custom tools. No, it's not. Something I find myself doing a lot with vibration analysis is looking at the mass participation factor. Now, if you have a model like this, let's just run a normal modes analysis on this model, and I'll show you what I'm talking about. All right, so I'm going to ask for my mass participation. All right, so here's my different modes. I can look at my mode shape, and I know my natural frequency. But if I was to be exciting this structure in a particular direction, I might want to know how much of the mass of the structure is actually participating in that mode, and which direction is it really moving in. And that's why I requested these mass participation factors. So I could take a look at a few of these, the translational directions, and I'll show these in charting. So here I can see my first mode is dominated by T3, or the Z direction. My second mode really doesn't have a whole lot of mass. The fifth mode has 55% of the mass participating in the Y direction. So this is very useful information, but I want to tie this back, I want to tie this back to the actual frequency values. Mode 1, mode 2, mode 3 doesn't really tell you a lot of information if you know your vibratory excitation is happening somewhere between 500 and 1000 hertz. Mode 1, you don't really know unless you go back and look here. So one of the programs that we have, this up, is used to tie together our results from our normal mode analysis. So it's going to go through and extract the natural frequencies from these output sets. And I'm also going to select all of these functions that the solver gave me. And what it gives me is new functions where I have my mass participation now shown as a function of frequency. So you could show this one chart. You don't have to tie back to what is mode 1 and mode 2. You have those frequency values across the bottom there. Okay, some of the more lighthearted and fun programs that we have in here. There's a lot of stuff with view settings. Before I went to engineering school at Oregon State, I was an art major and realized that wasn't going to work out so well, but still, I'm obsessed with making nice looking models. And so I'm constantly messing with the view settings and figuring out different things. So the API is a great way to do a lot of that. One of the things that I found interesting for a certain model was the light source in the model. Sometimes it's hard, you're trying to get a certain amount of shading so you can see the curvature of a certain structure, and it just doesn't work out quite right. So let me bring in some geometry here. And under view settings, I'm going to play with shading because good engineering is all about some nice shading here. We'll do that. Right, so that works out all right if it's oriented the right way. but maybe I want to move that light source around. This is another sort of loop type program where rather than modifying that in view settings, I can just press play, cycle this through, and get that light source to move around without actually going into those settings and changing those different parameters. Another one that I use very frequently, if we were to have a mesh on this part, is the feature line option. So within view options, you can use the feature line, and this is a nice way to show edges within your model. So let's do all. I'll turn this on, and when we turn off our geometry. So even if you don't have any geometry, but you're trying to highlight some features of the structure, some edges, free edges, sharp corners, you can use this feature line. But I found myself turning it on and off quite a bit. So this is another situation where I used the API. Let's see if I have this in this folder. Yeah. I'm not sure if I have it saved in this folder here. Okay, sorry about that. I will have that up on the website for you guys. But a lot of these are built off the same sort of core architecture. We talked before about maybe modifying something in the view to remove certain information. You wanted to show images of the model, but you didn't want to reveal certain things like the actual stress values. One of the programs here I just called the clean view, and this goes through and it removes the legend, titles, basically wipes out all these other entities, and you come back, you can run it again, and it turns them back on. So there's nice ways to save yourself a bunch of clicks. Now, it's still a bit obnoxious to have this window open here, hunting down different programs, opening them, hitting play. And that's where customizing toolbars can be very useful. So this is kind of the shortcut, just like custom tools gives you access to the programs within the FEMAP install directory. You can create custom toolbars. We'll call this one API. So here's an empty little toolbar here. And under user commands, I can go find these APIs, these programs, create a command out of them. And I think you actually have to close that to save that command. But now I have this user command saved here. I could drag that onto a toolbar, and now I have even quicker access to this particular program. You can set up different logos for this or icons if you want to set up something that looks a little bit nicer. So whatever you're using, whatever sort of macro you're trying to automate, geometry creation, meshing, post-processing, or silly little view settings like this, once you really find the initial program that maybe has some of the functionality that you need, you work through the help manual to modify it in a way that's really customized for your application. You can then create your user commands, have these buttons, and really have a very customized toolbar with just the commands that you need, easy access, and you know, it's really your own little custom toolbox that you have here. Okay, so that's actually it. I'm gonna wrap up, so we're on time for lunch. If you guys have questions about this, want to download this, let me know. I'll be over at the computer over there for lunch. I also wanted to mention that we're going to be having a FEMAP training opportunity coming up next month. This is a live online training. We break it up into half days, so you don't have to commit a full week. We'll be talking about some of the meshing, some of the programming, but yeah, it's broken up into 8 sessions over 2 weeks, half days, and I would recommend checking that out if you guys are looking for some more FEMAP training. Other than that, we'll break for lunch. I think we have 45 minutes for lunch. and then we'll be coming back to the developer roundtable. You guys have any questions for the group? Come find me later. Thank you.